Now that you've had a chance to explore the contents of the box, it's a time to have a look at the Arduino Uno in a bit more detail. The Uno itself is actually an 8-bit microcontroller. That means it's a type of computer, but it's very good at performing one operation repeatedly and automatically. You program it at the start, and then it's very good at reading information in and reading information out, making decisions and making things happen. What it's not good is general purpose computing, so you will never run Windows on this or even a version of Linux. But let's have a look at the actual Arduino itself and get a better look at what it's capable of. So this is the Arduino Uno. It has, running down the side, some black connectors on both sides. It's also got these little metal rings. If you were going to solder to the Arduino Uno, you would use these metal rings, but these black plastic blocks, which are called pin headers, are ideal for inserting these cables. So if you wanted to connect to, say, pin 10, you would look for where 10 is, reach across and just push it in, and now that wire is now connected to pin 10. It's very hard, as long as you're powering from the USB, to damage the Arduino Uno. The only way that is almost certain to guarantee damaging it is if you connect a pin which is marked G and D directly to a pin marked 5 volts. That's pretty much the easiest way to fry it. Now, all these pins that run down the side are a little bit hard to see. So instead of me zooming in on the board, what I've got is I've got a nice picture of it. So this is a picture of the Arduino Uno. The Arduinos you've been supplied with don't have the long chip on them anymore. They've got the small square one in the middle, but all the pins are still in the same place. Running down the left-hand side here, we have some voltage pins at the top. We won't use the first few of these too much, but the one which says 3.3 volts, that is a 3.3 volt supply that we can use to power circuits. The one marked 5 volts gives us a 5 volt supply, and the two which are marked ground give us our 0. In general, when you've got an electronic circuit, power is going to go from a high voltage, in this case 5 volts or 3.3. Because decimal points are a bit hard to read, often in electronics work we replace the decimal point with a letter. So in this case it's 3V3, meaning 3.3 volts. There is another one here marked V in. It is not something we're going to use very often because it doesn't have any power protection behind it. Again, supplying too much power there, and you can release the magic blue smoke from inside an Arduino, which you can't put back in. Below there are 6 pins marked A0 through to A5. In computing, we tend to count from 0 to 5 or 0 to 13. These analog pins that are marked with A, we will use them in some of our later projects to detect input voltages and detect sensors, but they can also be used as outputs. On the other side, we have digital pins 0 to 13. We don't write D0 to D13, we just write 0 to 13. Pins 1 and 0 are a little bit special in that those are actually connected inside the jack, inside the USB, to actually allow your computer to talk to the Arduino. So we'll use those 2 pins as our last ditch attempt if we run out of other sockets. The rest, pins 2 to pin 13, we can use as digital in or digital out. Digital here means it is either on, high, or true, or off, which can also be set to be false or low. Some of these pins have got a little squiggle next to them. So pin 3, pin 5, pin 6, 11, 10 and 9. Those are 6 special pins that we can turn off very quickly, which we call pulse width modulation. We will look at those later when we start controlling red, green and blue LEDs. But for the moment, we'll just leave them as if they're normal digital outputs. There is a 6-pin connector down here, which is used for programming the Arduino if you can't use the USB. We're generally not going to use that because it adds more complications than we need. And up here in the top right hand corner is the reset button. Pushing that reset button or pulling this reset line over here, the third socket on the left hand side, the second real pin, down to 0, will switch the Arduino off and on again. Always useful if something actually breaks. We push that button to double check what happens. Now the last thing you might notice is pin 13. If you follow all these lines across, the last symbol on it is a symbol for an LED. That is actually connected to the LED on the board. So anytime that you are using pin 13, the LED on the board will also come on and off. And that is this LED down here that we saw flashing when we checked that the Arduino could talk to the computer. Don't worry too much about these pins now. Just know that it's very hard to actually break it. We're going to have fun. We're going to build some circuits with this and we'll explore it. In our next video, we're just going to look at the breadboard and then we're going to build our first circuit. So, see you in the next video.